I'm Russ Strader of Data Communications Brokers. Data communications is a broad field linking many different types of equipment in different ways. One key element is the modem. Options for modems are nearly as numerous as the various communications links in which they are used. These options can be overwhelming, but don't have to be.
Look at this 2-inch stack of modem manuals. From these manuals, for only a half dozen modems, this was distilled. A 1/2-inch stack of index cards, one option per card. Collecting one manual for each of several hundred different models, the index card stack would probably be 6 inches high. Then an hour could be spent just reading the cards, leaving you totally confused. This is not the purpose of this tape. By narrowing our discussion of options to the basics, we can see the options and their functions more clearly. That's right, modem options don't have to be confusing. Organizing the wide variety of options into their small number of functions will help make order out of apparent chaos. Today, more and more modems are being integrated into other products, such as terminals, test equipment, multiplexers, printers, temperature and power control equipment. It's important not to confuse the modem options with the options and settings for the other equipment. No one sets out to build confusing equipment, but designers do have to respond to the needs of their customers. Modem options are the result of efforts to respond to the changing communications climate in which their modems are used. There are low-speed and high-speed transmission systems. Modems can be used dial-up over the switched phone network or used on private lines. Private lines, in turn, can be point-to-point or multi-point. The terminal devices can be synchronous or asynchronous. Let's begin with the most basic and original modem use, the low-speed acoustic coupler calling a computer. At the computer end, there are a couple of important answering modem options. These are typically limited to auto-answer, answer or originate mode, data terminal ready from the terminal, or forced on in the modem. The auto-answer feature must be on, of course, for an unattended modem at the computer. If, on the other hand, incoming calls will include both voice and data, the auto-answer feature should be turned off so your flesh and blood callers get you, not the modem. The answer mode or originate mode must often be selected before transmissions can be received or sent using the low-speed 300 bits per second modems. The modems in this category are acoustic couplers and 103 and 113 type models. The 103 and 113 model numbers originated with the Bell telephone modems. Data terminal ready is the signal that comes from the terminal to the modem on pin 20 of the RS-232C interface cable. Modems are designed to require pin 20 to be turned on before they will answer a call and hold the line open. When the data terminal ready signal comes from the terminal or computer, the data call can be terminated by turning off the signal on pin 20. It's sometimes desirable to force pin 20, data terminal ready, on in the modem if your terminal or RS-232 cable doesn't turn the signal on. These three options, auto answer on or off, answer or originate mode, data terminal ready, are the most important general dial-up modem options. Many dial-up modems have a few options for disconnecting from the phone call. Long space disconnect, line current disconnect, loss of carrier disconnect. The long space disconnect can come from the phone line side of the modem, or most typically the digital terminal side. A long space is 1 second or several seconds of digital zeros equal to plus voltage. This option exists in some, not all, dial-up modems. It's more often ignored than used. The line current disconnect option is found on some dial-up modems. The phone company applies several volts of direct current across the two wires used for dial-up calls. The phone company also interrupts the voltage to the receiving party when the caller disconnects the call. The receiving modem thus knows to disconnect the call and hang up the line. Typical options are short time for older type central offices, long for new electronic phone company central offices, or out for lines that are troubled by excessive current interrupts. Loss of carrier disconnect applies to dial-up modems at 2 times during a call. First of all, after a modem answers an incoming call, it will automatically hang up the phone if no carrier signal comes in from a remote modem within 15 seconds. Second, if carrier is lost during a call, it usually means the call has ended, so the modem should hang up the phone. The loss of carrier disconnect option, when available on modems, allows some flexibility in the length of time carrier can be lost. If a dial-up modem can also be used on a private line, it's desirable to disable the loss of carrier disconnect function. We can expand our selection of modem options by moving from the low-speed dial-up modem to the 212 type models capable of 300 or 1200 bits per second. The 212 type modems can be optioned for high-speed, low-speed, or both, asynchronous or synchronous operation, fixed or programmable transmit level. For answering applications, 212s automatically sense the correct speed, 300 or 1200 bits per second. For originating applications, 212 modems must be set by the user to run one of the 2 speeds. The speed is usually selected by a front panel switch or push button. While 212 type modems can be used for synchronous communications, a good guess is that 90% or more of 212 modems are used asynchronously. 212 modems can be optioned for asynchronous word lengths of 9, 10, and on some 11 bits. The typical word length is 10 bits. The 10 bits include 1 start bit, 7 data bits, 1 parity bit, and 1 stop bit, for a total of 10. There are almost no 9-bit applications. The 11-bit word length is usually limited to Wang and Nixdorf computers. The fixed or programmable transmit level applies to 212 modems and most other dial-up modems. In the more common fixed transmit level mode, the modem transmits at an energy level of -9 decibels. This level is required by the FCC. If the modem is set for the programmable level, the transmit level is actually set by the telephone company. The phone company sets levels using RJ41 or RJ45 jacks. 2 extra wires go from the modem to the phone company provided jack. The phone company puts a resistor across the 2 modem wires to set the transmit level. An open equals -12 decibels. A 5.47 thousand ohm resistor sets the level at -9 decibels. A short results in a 0 decibel transmit level. Some 212 modems can also be used on private lines. There are other modems too that can run on dial-up lines or dedicated private lines. A 1200 bits per second async modem, the 202 model, is available for dial or private line. 2 synchronous modems used for both dial and private line are the 2400 bits per second 201 models and the 4800 bits per second 208 models. When these models, the 202, 201, and 208 modems, are used for either dial or private line, they often have several options related to this dual function: 2-wire or 4-wire operation, output level, private line or direct connect. The 2-wire option is for dial-up lines and is also occasionally used for private line. 2-wire operation forces half duplex with 202, 201, and 208 modems, and with few exceptions saves nothing on phone line costs. 4-wire operation at 0 dB is typical for private lines. An output level of -9 decibels is typical for direct connect dial operation. With programmable output available on some modems, the phone company regulates the level in the jack connection. For the private line or direct connect options, direct connect is used for dial-up communications. The private line option is obviously used for private dedicated lines, whether they're point-to-point or multi-point. With the increased use of satellites in recent years, a satellite option has appeared. Satellites require new options because of the signal delay time. Satellites orbit the Earth 22,500 miles above the surface. Therefore, a one-way trip up and down is 43,000 miles, or almost 3/10 of a second, even at the speed of light. The satellite option affects call setup operation, allowing more time before data set ready turns on at the start of a call. After call setup, the modem may have an option to increase the request to send clear to send delays. Modems can have several options related to the signal levels and qualities: carrier detect level, signal quality retrain, signal quality abort. The carrier detect level sets the sensitivity of the receiving modem. The typical setting for a private line modem is -30 decibels. If a modem is used on lines with very low levels or on dial-up calls, the receive level is often set to -45 decibels. The lower level, -45, is more sensitive to background noise. Modems with signal quality retrain automatically and continually monitor the incoming signal level. When the signal level becomes too low or the noise level increases to too high a level, the modem will automatically attempt to retrain or retune itself to the incoming signal. Signal quality abort applies to some dial-up modems. These modems can be optioned so they disconnect a dial-up call if the signal is too poor for too long, perhaps 5 or more seconds during a call and after, 15 or 20 seconds during call answering. For multi-point modem operation, there are two key options and a third option that is becoming more common: controlled or constant carrier, request to send, clear to send delay, streaming modem disconnect. Constant carrier is used for point-to-point four-wire operation of modems. Controlled carrier must be used for all 201, 202, 28, and 9600 modem two-wire dial-up applications, and on all remote modem stations on multipoint lines. Controlled carrier is required for the remote modems for multi-drop lines because they all join their transmit lines together. The central site master modem can't listen to all remote stations at once, just to one remote modem at a time. The request to send, clear to send delay is usually the longest for dial-up use with 202, 201, and 208 modems. 150 milliseconds, about 1/6 of a second, is typical for dial-up. The delays are shorter for the multipoint private line applications. Generally, the faster the modem speed, the longer the request to send, clear to send delay. The central site receiving modem requires time to tune itself to the incoming signal before receiving data. High-speed modems with very short request to send, clear to send delays are called fast pole or fast train modems. Streaming modem disconnect results in a modem shutting off transmission from the attached terminal. The streaming modem disconnect should only be used at the remote end modems on multipoint lines. On a high-speed modem, the terminal should be able to transmit any message within much less than 45 seconds to a minute. If the terminal fails to turn off its request to send after 45 seconds or so, the streaming modem disconnect option results in the modem turning off its transmitter, even if the terminal request to send is still on. This allows the computer to proceed with service to other terminals on the multi-drop line. There are several options we haven't yet covered. Data set ready option, internal-external slave clock. The data set ready or DSR option applies to the test procedure on some modems. This option gives the choice of leaving data set ready on during test modes or turning data set ready off during testing. The rationale for turning DSR off is that the data set is not ready to transmit normal data during testing and is telling the terminal or computer not to assume normal operation until DSR is on. The reason for sometimes having DSR on during testing is that some test equipment may require the signal to be on before sending test data. The most typical setting is to have DSR off during loopback test. The clocking options apply to synchronous modems only. Internal clocks are used for most point-to-point and multipoint circuits. This modem with internal clocking option provides clock to the terminal on computer pins 15 and 17. External transmit clocking is used typically for a synchronous tail circuit. Tail circuits may be off a modem sharing unit or a lower speed circuit joining others into a higher speed trunk line. Slave timing is common for the remote modems on tail circuits. Slave timing means that the modem slaves its transmit clock to the received data clock. The slave can be used at only one end of a point-to-point circuit and at only the remote stations on a multi-point circuit. There are some miscellaneous options worth reviewing briefly. One is frame ground and signal ground strapping. These two grounds may be isolated or tied together. Frame ground is normally tied to signal ground at only one place in a system. Many modem manufacturers suggest when frame ground and signal ground be tied together at the modem, they should not be strapped together in the equipment connected to the modem. Some newer high-speed modems have an adjustment for the high-frequency parts of the modem signals. The adjustments allow for either boosting the transmit signal or making the receiving end more sensitive to the incoming signal. These high-frequency adjustments are sometimes necessary because the high-frequency portions of the signal suffer more transmission level losses over some phone lines. There are a few modem options related to controlling speeds and loopbacks through either front panel controls or through the RS-232C interface connector. In most cases, speeds and loopbacks are controlled on the front panel rather than through the RS-232C connector. Many modem manufacturers list suggested options in appendix tables. This manual has recommendations for 4-wire private line, 2-wire private line, 2-wire dial-up. Use the manual tables where available. When not available, categorize the use of the modem first. Then the various options make more sense. Categorize by uses such as dial or private line, point-to-point or multipoint, synchronous or asynchronous. As you can see, there are a number of modem options. However, by carefully following the manuals and relating the options to the use in your system, much of the mystery of these options disappears. You don't have to be an engineer. You don't have to be overwhelmed.